Welcome back to our class. Now today we'll be considering the concept standard form. Another name to standard form is scientific notation form. So we say we use this to re-express very large number, especially when you have a number that is large. It's good or advisable that you express it in a concise form called the standard form. So, and the expression will be in the form d times 10 to the power of n, where d will be a decimal and n here will be an integer, will be positive integer or negative integer, and could be 0. So as we will see here, we have express each of these numbers, in a scientific notation form. So in this case, the first one, which is 3,000, if you want to express it in a scientific notation form, in this one, you know, this one is like, it's like 3 times 1,000. And if you have 3 times 1,000, if you have 3 times 1,000, so that is the same thing as 3 times 10 to the power of 3. But in this case, since 3,000 is whole number, there is invisible, it's like 3, there's invisible decimal points here. So it's like you have 3,000.0. So, and you will now need to move, when you want to express this, so you will have to move this decimal to behind the first non-zero digit. So in this case, we have jumped over 3 digits. So the value will become, if you move the decimal to behind 0, to behind 3, it will become 3.0. That means 3 is same thing as 3.0. You now say times 10 to the power of, the power now is a function of how many times do you have to move over digits before you get to the back of 3 here, which is the first non-zero digits. So you move 3 times here, so it will be power of 3. Then the second one, if you look at it, you has the decimal, this is 456.0. So if you need to move the decimal to behind the first digit, the first non-zero digit, so it will be 4.56, that's the decimal part. You now say times 10 to the power of 2, because we have to jump over 2 digits before we get to behind 4 to the power of 2. Now, it is good that we note that all these power are positive, because the number we are expressing in scientific notation form, each of these numbers is greater than 1. 3,000 is greater than 1, so the power of 10 will be positive for it. 456 is greater than 1, the power of 10 will be positive for it. So let us look at this one. Numbers, this C part, since the decimal already appears, good. We move the decimal to the back of the first non-zero digit, which is to the back of 7. And this will give us 7 points. Then you write the remaining digit 253. So you will say times 10 to the power of, how many times did you have to move the decimal to get to behind 7? It's once. So to the power of 1. It is important for us to know that 10 to the power of 1 is still 10. For this C, now the difference between A, B, and C, the difference between the number we have from A to C and the one we have between D and E is that number A to C are numbers greater than 1. If you look at all the numbers, they are greater than 1. That is why the power of 10, all the powers of 10 here are positive. So for this one, 0.898 is a number less than 1 because it starts with 0. The whole number part is 0. So that means the whole of this one is less than 1 already. So likewise, that of E part here, this E is also less than 1. So the power of 10 in this case will be negative. So now what you do is that it will be, the decimal appears here. How many times do you have to jump to before you move the decimal to behind the first non-zero digit? That is it. That means you can see that the movement here is not going backward, it's going forward. So it will be, this would simply be 8.98 times 10 to the power of, since you have to move once before you get to the back of the first non-zero digit, you have to move once. So it will be -1. It is -1 because the whole the number you are expressing in this standard form is in itself less than 1. So lastly for this, if you look at this, if you want to move this decimal to behind the first non-zero digit, you have to jump this way. So to the back of 3 here, which will produce 3 point nothing. That's 3.0 times 10. Then the power of 10 now is how many digits did you jump over? You have 1, 2, 3, 4, 5. That is -5. I want us to quickly express the following numbers. Express the following numbers in index form. Exercise. Express the standard form. A, B, 0.049. All right, thank you.